Okay, so in this video, I'm going to show you how to find and use the binomial CDF. So the difference between a binomial PDF and a binomial CDF is that on the PDF, it finds an exact probability of a specific outcome. On the CDF, it finds the probability of all the outcomes leading up to that. So if you imagined a distribution table and you had like probability of event 1, 2, 3, 4, 5, and 6, it would add up all of them up to a particular value. And that particular value on our wizard is the x value, or the lowercase x value. So if you haven't watched the other video, this might not make sense unless I walk through this part, so I will. So what are the chances of cutting a face card more than 3 times in 6 attempts? Let's let x, capital X, be the discrete random variable for the number of face cards cut. Now, as calculated before, there are 3 face cards out of 13 of each suit. So 3 over 13 is the probability of success here. So I know that my probability of success is 3 to 13. So I know that x is distributed binomially. There are 6 attempts, so 6 trials, and the probability of success is 3 over 13. And this question is saying more than 3 times. So I want to find the probability that x is greater than 3. Now the probability that x is greater than 3 is equal to 1 minus the probability that x is less than or equal to 3. Now, it's important to note that when you see inequalities, the inequality indicates that you're going to use the cumulative distribution function. Now, with some inequalities and with some distribution functions, we have the ability to state whether we're looking for below or above a particular point. But with the binomial distribution function, we have to look from the least amount of successes up to a particular number of successes. So greater than doesn't really help us. So we have to convert it using the complement to less than. And because it works out on our wizard that it'll calculate up to this particular boundary, we have to convert it to a less than or equal to. Now I should note that the probability that x is less than or equal to 3 is the exact same as the probability that x is less than 4, because the outcomes for this are discrete numbers. You can only have 1, 2, 3, 4, 5, 6, or 0 face cards being cut. So now that I have this, I'm actually going to start to type this out in my calculator. Now I could type 1 minus, and in fact I'm going to. So I'm going to start off by doing 1 minus. And then this part is found using the probability, the cumulative distribution function. So it's second function, vars, and it's a binomial experiment, so binomial CDF this time, not PDF, CDF. My number of trials is 6. My probability of success is still 3 over 13. And my x value, whatever value I type here, is going to calculate from 0 successes up to and including this number of successes. So I'll type in 3 because I want up to and including 3 successes. And then I'll paste. And you'll see that this is going to leave me with 1 minus the binomial, this expression. So this is the calculator type that represents this expression. On a test, you need to show me this. And then you can simply write the answer. You should never show me this on a test. Same thing for the IB exam as well too. So go ahead and hit enter, and the probability of this happening to 3 significant figures is 2.83%, or 0.0283. There is a 2.83% chance of this. So that's a little better than 1 in 40. So not very likely that this is going to happen, but it's still a pretty cool thing. Okay.